Hi viewers, today we are going to discuss about SVM support vector machine. So support vector machine is a supervised machine learning algorithm. This is used for classifying regression type of problems, and with use of a hyperplane we are just using the negative class and positive class to classify the two classes. We are using this type of algorithms. So in our discussion of previous algorithms, whatever we learned, all are in the same category. That is, it will be a classification algorithm. The same way we are discussing the further algorithm, that is to be the SVM algorithm. So in this regard, we will start the coding part, and I will show you the hyperplane first. So how the hyperplane is plotted for SVM. So I hope you can able to see the hyperplane here. So this hyperplane contains x and y axis. So in that we are having a negative hyperplane and a positive hyperplane, and this is the class A, and let's consider this is a class B, whatever you are seeing as a square and dots. So in this particular thing, it used to classify the two different classes in a perfect manner with use of SVM. So in regression problems, we are telling that we are having two different attributes that are said to be positive, that is said to be dependent attribute and independent attribute, like that we will tell dependent variables, independent variables, like that. In that case, let's consider age and salary. Okay, when we are taking age and salary, age is whatever the salary we are taking, that is dependent on age. So age will be increased according to the age, the salary will be dependent. So if age is increasing, your salary also increased, like that. So this type of regression problems will be solved by SVM. So SVM is a good example for regression problems. Okay, so in this regard, let's go for the program part. So here we are just having NumPy package and matplotlib package and pandas package. So these three packages are very important packages in all machine learning algorithms. So NumPy is used for numerical Python to do numerical calculations, mathematical calculations in Python. We are using NumPy. Next to that, we are just using matplotlib. Matplotlib is used to plot the graphs. So in machine learning, the input is said to be data sets, and whatever the output we are displaying, that is in the form of charts. It may be in the form of bar charts or pie charts or scatter graphs. So we are producing the output in the form of graphs. Okay, so that we need a package for doing this process, so that will be done by matplotlib. Okay, so next to that, we are having pandas package. So pandas package is very much useful to get the input, whatever the CSV file we are having, whatever the data set we are having, that has to be readed, and we have to process the data set. The data set has to be converted in the form of data frame data type. So initially the data set will be in the form of CSV file that has to be converted into data frame. So that part will be taken care by pandas package. So pandas package having a inbuilt method called read underscore CSV. That particular method is used to convert the CSV file in the form of data frame. Not only CSV, can give Excel also. Okay, so that is also taken as an input. So let's execute this particular thing. When you are executing this particular package, we are importing the package, three packages, that is to be NumPy, matplotlib and pandas. These three we executed here. Next to that, we are having a data set. Our data set name is social network ads. So social network ads we have to read, and that has to be stored in data set variable, and further we are converting in the form of x and y. So let's execute this particular code and see the output for this. So we executed. So let's see what the data set we are having. So when you are opening the data set, you can able to see the data set. It contains age, estimated salary and purchase. So this are the three columns we are having in the data set. So what this data set contains, what this data set replicate. Whenever you are getting some data, you have to do the analysis. Age and salary, so both will be having some relation. Whenever age increases, salary also increases. So that is the thing. The third one is our target, whether the person will purchase the product or not. Okay, I am running a business. Okay, in my business, whether the person who is coming to the shop, he will purchase my product or not. Okay, if he is purchasing, then I can able to identify which category of peoples are purchasing my product. Whether the person having salary more than 60,000 or age more than this range or this category of range, whether he is a teenage person or he is a mid-age person or he is a elder person, like that I can able to categorize. So according to that I can attract the customers. So target customers I have to find out. So that is the prediction. So with use of this prediction we can able to increase the business models. So that's what the data scientists are doing in nowadays. Okay, so in this case we are having age, estimated salary and purchased case. So these three columns we are just giving us input. In this 0 and 1 we are having no, the purchase 0 mean by the person not purchased the product, 1 mean by he purchased. Okay, so in this we are keeping 25% as a test set and remaining 75 as a training set. With use of this split up we are just doing the process. Here we are just splitting x and y. So x will be first two columns, y will be only the last column, that is to be the class column. Whether the person purchased or not we are identifying. So I will show the x and y value. So x is said to be the first, so that is said to be age and the salary, estimated salary. Y is said to be the last column what we are having, whether he purchased or not purchased. Okay. Next to that what we are having, we are just having the training and testing split up. So training and testing split up, how we are doing, we are with use of the predefined method or the package what we are having, that is said to be model selection. So from model selection we are having a method called train underscore test underscore split. With use of that method we are just doing this process. We are passing x, y as well as we are passing the test size, so that with use of the test size we can able to split the x train, x test, y train, y test. So according to that we are having how many rows we are having in the particular data set. We are having 400 rows in the data set. In that 25% is said to be 100 rows. So 100 rows will be taken for test set, remaining 300 will be taken for training set. So what is mean by training set and what is mean by test set? You are training the machine learning model with use of training set. So you are giving information about the given data set. So this is the data set. In this category of peoples are having this salary and they purchased or not, like that we are just giving information to the machine learning model. For the 25% we are just taking as a testing set. So we are not giving the class column, that is mean by whether they purchased or not, that we are not giving, and we are just feeding the input. Only the first two columns we are feeding as input. With use of that first two columns the model will just predict the results. The last column what I told, no, whether they purchased or not, that column will be predicted by the model, so that we are comparing the predicted result with the actual result. So if both are matching we are giving that the 100% accuracy we got. If it is if the prediction happens for 50%, mean by among 100 rows 50 rows are correctly predicted and remaining 50 rows are wrongly predicted, means what we have to decide, the model is 50% accuracy, the model produced 50% accuracy, like that. Okay, so in this regard let's execute the next code. So this code just I am re-executing because already I executed and I got the output. So here we are executing the same code again for understanding purpose. So here the code got executed. So I got the x train, x test, y train, y test. Then I am doing a feature scaling process. So feature scaling process I am doing with x train and x test. So let's execute the feature scaling process. So x train will be modified. You can able to see before that the age and the salary was there here. So there is a huge deviation between those values, so that we have to convert the values in the form of decimal numbers, so that we can give that inputs to the classification algorithm to get better accuracy. If you are feeding the same thing, your accuracy will be dropped down because there is a huge deviation between the numbers. So one person getting 1,50,000 salary, another person is getting 30,000 salary or 25,000 salary. So there is a huge deviation between numbers. So that numbers is not possible to give as an input. So in this regard, we have to correctly manipulate the data with use of feature scaling. So we have to scale the values so that feature scaling algorithm worked out here, and we are getting the output like this. You can able to see the output here, no? The way we getting the output like this. Then further what we are doing, we are just making our support vector machine algorithm. So SVM, it import SVC. So SVC, what it happens, we are using a kernel. So it's a kernel SVM, so that we are just using different kernels, linear kernel, cosine kernel, then RBF kernel. All these kernels are there. So these kernels we can use for doing this process. So here we are using linear kernel. So with use of that, I am executing the classification algorithm. So my classification algorithm executed fine, and I am just checking my predicted value. So as I told, the machine learning algorithm will predict the values, no? So what I predicted, I can able to see in ypred. So ypred is my predicted value. What is my actual value? Y-test what I am seeing here, this is my actual value. So this is the actual value what I got in the data set. So this is the value. Ypred is said to be the value what I got in the model. Okay. So after my execution of classification algorithm, I got this results. So this two will be compared. How many of the rows are correctly? Totally we are having 100 rows in the both the thing. Mean by 0 to 99 we are having in both Y-test as well as ypred. So both will be compared. In the comparison, how many of them are correctly predicted? How many of them are matching? So that is to be the accuracy. So the accuracy, we are just comparing Y-test and ypred here, no? So for that we are identifying the confusion matrix. So confusion matrix is the matrix that is used to produce the correctly predicted values will become in the diagonals. So diagonal value what we are getting, that are to be correctly predicted values. So let's execute the confusion matrix and see how the confusion matrix executed. And I am opening the confusion matrix. So here, as I told, we are having 100 rows of test set. Among 100 rows we are getting 66 plus 24, so that we are getting 90 rows are correctly predicted and 10 rows are wrongly predicted. So you can able to see, apart from diagonal, we are having 8 plus 2, so 10 rows are wrongly predicted. Okay, so I am calculating the accuracy now. So accuracy will be calculated with use of Y-test and ypred. Comparing this two, we are getting the accuracy. So accuracy we will get 90%. So I got the accuracy, you can able to see 0.9. 0.9 mean by 90%. You can see the accuracy here in the console window. So that's it, viewers. I hope you understand the coding explanation of SVM. Support vector machine used to produce good accuracy with the same data set we taken in different algorithms. Each and every algorithm produces different accuracy. 89 produced by the logistic regression, and 92 produced by KNN. So there are different deviation in accuracies. So we have to execute different algorithms, and we have to analyze the accuracy, and we can fix a particular algorithm that will be best fit for that data set. Whatever the data set we are getting, for the data set, which algorithm will be best fit, that we have to identify by doing this type of executions. Okay, so thank you for watching. Share, subscribe and support. Thank you very much.